Here we have a geometry problem. Okay, let's go the information. In the figure below, the line segments AC and DE are parallel. Find the length of DA and the AC. So we have to find the length of the two line segments DA and AC. Okay, let me assume the length of the line segment DA as X and the length of the line segment AC as Y. Okay, there is an information in the question, that is the line segments AC and DE are parallel. In this line segment AC and DE are parallel because and also we have markings over here. Okay, whenever two lines are parallel and the third line which intersects both the parallel lines are called transversal. And also when two parallel lines are intersected by the third line, I mean transversal, the two angle measure over here are called corresponding angles and they must be equal in measure. So there is the angle measure we have at the vertex D over here and A over here must be equal. And also here again the two parallel line segments AC and DE are intersected by the another line segment BC. So BC is also called the transversal and these two angle measures are called corresponding angles and they must be equal in measure. Okay, now let's consider two triangles in this figure. The smaller triangle BDE and the bigger triangle BAC. And this angle measure over here is a common angle for both the triangles, I mean angle measure B. Okay, so the three angle measures of the smaller triangle are equal to the three angle measures of the bigger triangle ABC. So the two triangles must be similar. So whenever three angle measures of one triangle are congruent or equal to the three angle measures of another triangle, then the two triangles are said to be similar. Okay, now let's write the vertices in order. First, let me take the vertices from the smaller triangle BDE. First, I'm taking the vertex B in the smaller triangle. So what is the corresponding vertex in the bigger triangle? In bigger triangle also we have the same vertex B. Okay, now let me take the vertex D in the smaller triangle. What is the corresponding vertex in the bigger triangle? It's A, because the angle measure at A and D are equal. So the vertex corresponding to D in smaller triangle is A in the bigger triangle. So if I take the vertex D in the smaller triangle, the corresponding vertex in the bigger triangle is A. And now let me take the vertex E in the smaller triangle and the corresponding vertex in the bigger triangle is C, because E and the angle measure at A and the angle measure C are equal. So these two triangles are similar. Okay, if two triangles are similar, then the corresponding sides are proportional. That is, if I find the ratio between the corresponding sides, they must be equal. For example, if I consider the side which is covered by the first letter and second letter over here, that is, I consider the side BD in the smaller triangle. What is the corresponding side in the bigger triangle? So we have to consider the letters of the same portion. That is the side covered by the first letter and second letter, that is BA. Okay, now I'm taking the side covered by the second letter over here and third letter over here, DE. So what is the corresponding side in the bigger triangle? So the letters are the same portion, AC. And now let me take the side BE in the smaller triangle. What is the corresponding side in the bigger triangle? BC. Okay, now let's plug in the lengths. What is the length of BD? It's 6. And what is the length of BA? So if I want to get the length of BA, I have to add this 6 and X. The length of BA is 6 positive X, or it can also be written as X positive 6. And what is the length of DE? So the length of DE is 10 and the length of AC is Y. What is the length of BE? It's 8. And what is the length of BC? To get the length of BC, I have to add this 8 and 12. When I add them, I'm getting 20. So the length of BC is 20. Okay, I think we can simplify this fraction. So here 4 goes into 8 twice and 4 goes into 20 5 times. Okay, so we can write 6 over X positive 6 equals to 10 over Y equals to 2 over 5. Okay, here we have 3 fractions are equal. So if I want, I can equate any two of out of these 3 fractions, equate. So I'm going to equate the first fraction and third fraction because all of them are equal. I can equate any 2 fractions. Why should I equate only the first fraction, third fraction? Because in the first fraction, the part of the denominator is unknown, that is X. But in the second fraction, both numerator and denominator are known values, that is 2 over 5. So if I equate the first fraction and second fraction, I can solve for the unknown X, so which represents the length of the side DA. Okay, let me equate the first fraction 6 over X positive 6 equals to 2 over 5. Okay, so since I'm trying to solve for X, but if I have this variable X in numerator, it will be easier for me to solve. So for that, I'm going to take reciprocal on both sides. If I take reciprocal for this one, I'm getting X positive 6 over 6 equals to 5 over 2. Okay, so let me multiply both sides by 6 because I have to isolate x. So this 6 will cancel out and 2 goes into 2 1 times, 2 goes into 6 thrice. So x positive 6 equals to 5 times 3 is 15. Okay, now let me subtract 6 from both sides. When I subtract 6 from both sides, it's positive 6, negative 6 will cancel out. When I subtract 6 from 15, I'm getting 9. So I got x equals to 9, but x represents the length of dA. So therefore, the length of the line segment dA equals to 9 units. Okay, now what we can do is we can equate the second fraction and third fraction, because in the second fraction there is an unknown y in denominator. In third fraction both the values are known values. Okay, let me equate it. So 10 over y equals to 2 over 5. Okay, now let's get the variable, I mean unknown, to numerator. For that I have to take reciprocal on both sides. If I take reciprocal on both sides, I'm getting y over 10 is equal to 5 over 2. Okay, to solve for y, I have to multiply both sides by 10. When I multiply both sides by 10, this 10 will cancel out. 2 goes into 2 1 times, 2 goes into 10 5 times. So y equals to 5 times 5 is 25. Actually, y represents the length of AC. Therefore, the length of the line segment AC equals to 25.